students. Today we are beginning Module 11, and Module 11 is all about quadratic functions. So let's look at our learning target for Module 11.1. And in Module 11.1, we are graphing quadratic functions. So our learning target, I can analyze graphs of quadratic functions. I can graph quadratic functions by using key features and tables. I can use graphing calculators to analyze key features of quadratic functions. So first and foremost, let's look at what a quadratic function is. Now, a quadratic function is a nonlinear function. Okay, and the graph of a quadratic function looks like a parabola. So it is curved either up or it's curved down. Okay, and the equation of a quadratic function, because it's a second degree polynomial, so we have f of x, which is my function equation for that. F of x is equal to ax squared plus bx plus c. And of course, a cannot be equal to 0. And I can also write f of x is equal to y is equal to ax squared plus bx plus c. Okay, so that is my equation for a quadratic function. Now, the parabola again is the graph of a quadratic function, and it is a curved shape. So once again, it can be this way or it can be this way. It depends on the leading coefficient, and we will talk about that in a minute, whether it's positive or whether it is negative. Okay, so now let's look at the vertex form. A quadratic function written to show the position of its vertex. And that is important for us to know because that's where the axis of symmetry is going to be cutting through the vertex. Okay, so the vertex form is f of x is equal to a, and then we have x minus h squared plus k. And so we can, we've done translations and all kinds of transformations, which I can see over here, but we'll talk about that later on. Right now, let's just focus on this format. And looking at this, I can see that my h is going to be my x, and my k, which is the constant, will be the y. And so my axis of symmetry is going to be in this format. My x is going to equal h in this. All right, so let's talk about what is the axis of symmetry. So parabolas are symmetric about a central line called the axis of symmetry. And the axis of symmetry intersects a parabola at the vertex. Okay, so the axis of symmetry, now whether we have this, okay, it might be going this way. And so both sides are going to be symmetric. So it can be either curved up or, see, or it can open down. So it can open down like this. Okay, so it can be, it can open up or it can open down. So once again, if my f of x, so this is a vertex, is the lowest, or the highest. So if it's curved upward, if it opens up, my vertex is the lowest point. And if it is opening down, my vertex is the highest point. Okay, so it's the lowest or highest point of a parabola. And then if f of x is equal to x squared, so that means it is a positive a, right? And so what's going to happen in this case? It is going to be, it's going to be, if x is a positive, if my coefficient, then have x squared, f of x is equal to x squared, and that's a positive value, then it's going to open up. If it is a negative value, it is going to open down. So these are some of the key features of a quadratic function. And so once again, a quadratic function has an equation in the form where y is equal to ax squared plus bx plus c. So this is a basic quadratic function equation, okay? And then of course we know that the graph is called a parabola because that's what it looks like. And when a is greater than 0, the graph of y is equal to ax squared plus bx plus c. So that's what I was saying. It's positive, it's greater than 0. Then it is going to be curved up, or it opens up. Okay, so therefore in this case the minimum point of the vertex is going to be down here. Okay, so the graph has a minimum at the lowest point. Okay, and then when the graph is less than, when your a is less than 0. Okay, so it's a negative, and that's what we were talking about just now. Then what's going to happen? That in this case, your graph is going to open down, and then the maximum of that graph, it's going to be at the highest point over here. Okay, so the vertex is going to be at the highest point. Okay, so now the leading coefficient determines the end behavior of a quadratic function. Okay, so we'll talk about all of this in a minute. So let's go ahead to my whiteboard, and we are going to try to identify the axis of symmetry. Okay, so we're going to identify the characteristics. We're going to graph with the x-intercept. Okay, so let's pull up this. All right, now, so let's look at our graph over here, and there are certain things that we are identifying. We are identifying the axis of symmetry, and we are looking at where's the vertex. We are trying to identify the y-intercept of the graph, and then we are going to describe the end behavior. Okay, so let's look at this. And so if I look at, first thing I need to do is draw a straight line for the axis of symmetry. So that means where is the vertex touching, and here we go, because it intersects at the vertex. So we know that the axis of symmetry intersects a parabola at the vertex. So that is why we are making this line. This is my axis of symmetry line. Okay, so where is my axis of symmetry? This is going to be here. What is x in there? It is -2. So this is -2. So x is equal to -2, and that is my axis of symmetry. Then I'm going to look at the vertex. And the vertex is located in this graph at the maximum point. Okay, so this is the point that I need to be looking at. Okay, so let me do this color. All right, here we go. This is the point that I am looking at. So this is -2, and we have 8. So my vertex is -2, 8. Okay, then I'm going to look at where does the parabola cross the y-axis, and where do I see that? Over here. So it's crossing the y-axis at 0, 4. So therefore my y-intercept is 4. My y-intercept is 4. Okay, so this is my y-intercept. And then I'm looking at, let's look at the end behavior. As x is increasing or it is decreasing, what is going on with y? Y is also decreasing. So the end behavior is telling me that as x is increasing or x is decreasing, as you can see, my y is also decreasing. Okay? All right, let's do another example. And we are identifying the characteristics, and we are going to graph with x-intercept. So we are going to identify the axis of symmetry. the vertex and the y-intercept of the graph, and then we're going to describe the end behavior. So let's look at where is the axis of symmetry. So if I'm looking at this, I'm going to draw my line, which is the axis of symmetry, and of course it has to go through the vertex of the parabola. So there you go. What is x over here? It is 2. So my axis of symmetry, x is equal to 2. Okay, so let's look at where's the vertex. So the vertex is here. Okay, and so what is the ordered pair? 2, 16. Okay, so my ordered pair is 2, 16. And then you're going to look at where is the y-intercept. So that is where, the graph is being cut or intersected on the y-axis, which is over here. Okay, and so the y-intercept is 12 because my ordered pair is 0, 12 for that one. Let's look at the end behavior. As x increases, as x is increasing, what is happening to y? Y is decreasing, so y decreases. Okay, and then let's look at what happens as x decreases. So as x is decreasing, y is also decreasing. Okay, so as x decreases, y also decreases. So these are the characteristics of this quadratic equation. Okay, so let's do another one. We are again identifying the characteristics of the graph. Okay, and so let's look at this one. Again, we are talking about the axis of symmetry. That means where is x, the vertex, y-intercept, end behavior, etc. Okay, so when I look at this one, I can see that the axis of symmetry, where is this line cutting the parabola over here? So what is my axis of symmetry is going to be where x is equal to 0. Okay, so axis of symmetry is where x in this case is 0. Now let's look at where is the vertex located. So my vertex is located at 0, 3. Okay, and that is my ordered pair. So it's located at the minimum point, which is going to be 0, 3. Okay, then I'm going to look at, so what is the y-intercept if it's located at 0, 3? Yeah, the y-intercept is 3. Okay, y-intercept is 3. And then I'm looking at the end behavior. What is happening? As x increases, what happens to y? Y is also increasing. Y also increases. As x decreases, y also is increasing. Okay, so it doesn't matter because both ways is going to go up. If x is increasing, y is increasing. If x is decreasing, y is still increasing. Okay, so that because the parabola is opening up. Okay, so opens up. So that is why we have this end behavior. Okay, so let's do one more example so that you understand this concept well, and we are identifying the characteristics. Okay, so let's look at the axis of symmetry. So axis of symmetry, again I'm going to draw my line which is going through the vertex, and there's a dashed line. I'm just showing you the axis of symmetry. So I can see, where is this? This is at -3. Right? So my axis of symmetry, x is equal to -3. Okay? Then let's look at where is the vertex. So that is here. Okay? And so that is going to be at -3 and 3. So my vertex is at negative 3 and 3. Okay, then let's look at where is the y-intercept. So we can see that here is where it is intersecting on the y-axis, and that tells me that the ordered pair is 0, 12. So my y-intercept is 12. Let's look at the end behavior. As x increases, y increases. Okay, and because what is this? It's opening up, right? And then as x decreases, y is also increasing. It increases because it's a parabola. In this case, we can see that it is opening up. So the end behavior, y is going to increase either way, whether x is increasing or decreasing. Okay, all right. So now we are going to graph quadratic functions, and there are certain steps that I want you to remember. Okay, so first thing that we need to do when we are graphing quadratic functions is to find the equation of the axis of symmetry, and that is written with x is equal to opposite of b over 2a. So if you remember the quadratic equation form that I had told you, it was f of x is equal to ax squared plus bx plus c. Okay, so here my a, my b, my, the a and b are the coefficients. So this is what if I take whatever the coefficient is over here, opposite of that. So I get negative b, okay, and then over 2 times what is a, and that is going to give me the axis of symmetry. And so that is the formula for the axis of symmetry. Okay, so once again, from this format you can see this was my quadratic function equation. I'm going to do opposite of whatever b is, so that is why it's negative b over 2 times a. And so this is the formula that I am going to write down. And I can also write it like this. I can also write it with the negative sign in the front, because that's what it's going to become. Okay, so now next we are going to find the vertex and determine whether it is a maximum or a minimum. So it'll let us know, is it opening, is the curve, is it opening up or down? Okay, so that's what the vertex is going to tell us. We're going to find the y-intercept, and then we are going to use symmetry to find additional points on the graph if necessary, and then we are going to connect them with a smooth curve. Okay, so of course the first step once again is to find the equation of the axis of symmetry. So let me take you to my whiteboard, and we are going to do exactly what I just said. All right, so let's look at this problem, and it's asking us to graph f of x is equal to x squared plus 2x minus 6. Okay, so once again, please remember that if I have nothing over here, what is my coefficient is 1. Okay, so please remember our formula again for quadratic function, where we have y is equal to ax squared plus bx plus c, right? So this is nothing but a, this is nothing but b. So once I have that, I'm going to go ahead and use my formula for my axis of symmetry, where I have x is equal to negative opposite of 2 over 2 times a. So what is my opposite of 2 is going to be negative 2. Okay, so I'm trying to find that. So I have negative 2 over 2 times. What is a? As I just showed you, it is going to be 1. Okay, and so now when I look at this and I have negative 2 divided by 2, I am going to get my axis of symmetry as negative 1. Negative 1. All right, so now what I'm going to go ahead and do, before I do anything else, I'm going to go to -1 and I am going to just draw my dotted line to tell me where my axis of symmetry is. So this is my axis of symmetry. Okay, so my vertex is going to fall on this axis of symmetry, which is at -1. Okay, so I hope you can see that red. I can just do it with the blue if that makes it better. I don't know. But there is my axis of symmetry, which is at -1. So this line is my axis of symmetry. So I always like to put that out because I know my vertex is going to fall over there, and then my parabola is going to be symmetric on both sides of that. Okay? All right. So because the axis of symmetry, so first we did was we found the axis of symmetry, right? Next we are going to find the vertex. We are going to find the vertex. And to find the vertex, because the axis of symmetry passes through the vertex, we are going to use -1 as the coordinate of the vertex, and then we are going to find the y coordinate using my original equation. And my original equation is f of x is equal to x squared plus 2x minus 6. Okay, so that is my original equation that I have over there, and I already know that what is my x is -1. So I'm going to substitute this into that equation to find out what is my y. All right, so therefore, let me go ahead, and my x squared is what? I just calculated the axis of symmetry, x is -1. So I'm substituting this into my equation, and this becomes -1 squared plus 2 times -1 minus 6. Okay, and then when I solve this and I simplify this, I get -7. So therefore, the vertex lies at, my vertex lies at x -1, y -7. Okay, and because A is positive, see, x is positive, then I know that the graph is going to open up. If it was negative, it would open down. But because this is positive, because it's x squared, it's going to open up, and that tells me that my vertex is the lowest point in the graph. Okay, or it is a minimum. So I'm going to go and plot the vertex, and that is at -1, -7. So here is my vertex, okay? -1, -7. So I've gone and plotted this. Next, I'm going to find the y-intercept. And y-intercept means that my x is going to be 0 over there, because 0, whatever, right? That's the ordered pair. So I'm going to go ahead now, and I am going to use the same equation to find the y-intercept. Okay, and I am going to take that same equation, which is f of x is equal to x squared plus 2x minus 6. And I told you that where we have y-intercept, it is 0 something, right? Because x, so we have 0, and then we have to find out what is y. So instead of x, I am just going to substitute the value and put that 0. So this is 0 squared plus 2 times 0 minus 6. So when I simplify, what am I left with? -6. So here, 0, -6, and that is my y-intercept. So I know that here we have 0, -6. So this is my y-intercept. Okay? This is my y-intercept. So I can see that next that I need to do is I need to use the axis of symmetry. Now we're going to find additional points. Okay, so now we're going to find additional points. So what we can do is, first and foremost, I can see, you know that this is symmetric, right? So if I've already plotted this on this side, I can plot the same thing on the other side. So I can see from here, this is 1, okay? So I'm going to go 1 to the left here. So this is my one of the points for the curve because it's symmetric on both sides, okay? Now, let me go ahead and plot some other points, and let me plot another one. And let's say, let x be equal to 2. And then I'm going to substitute those values. So if I say, let x be equal to 2, okay, I normally like to take the right side because then I can reflect the same thing on the left. So if I'm saying x is equal to 2, let's see what happens in that equation. And I'm going to have f of x is equal to x squared plus 2x minus 6. So if x squared, that is, what is, if I said x is 2, I'm just going to write it here so that we have room, okay, here. So what is x? I said x is 2, so we have 2 squared plus 2 times x, that is times 2, right? And then I have minus 6. And when I solve this, I am going to simplify and I get 2. Okay, so now I have found this additional point. So when x is 2, my y is 2. So that is my ordered pair. So I'm going to go to 2 and 2. So here is the ordered pair for 2. When x is 2, y is 2, and that's what I just calculated. So what I'm going to do is, since this is 1, 2, 3 away from the axis of symmetry, I'm going to do the same thing on the other side from the axis of symmetry. So look, from here I'm going to go 1, 2, 3 because it is symmetric. The parabola is symmetric across the axis of symmetry. Okay, so then after that, once I have found all of these, then I am going to go ahead and I am going to connect the parabola with a smooth curve. So I'm going to go this way, and it's not very easy to show it on the whiteboard, but I'll try my best. Oops, as I said, it's not very easy to show it on the whiteboard. There we go. So, and there you go. All right, so this again, pretty simple, clear cut. Let me walk you through these steps once again. So when we are graphing, we know that my quadratic equation function in standard form is written like this. Okay, and so if I'm trying to find the axis of symmetry and I've been given an equation, I'm going to do the opposite of b over 2a. And that I'm going to substitute the values from the standard form of the quadratic equation. And so then I am going to find the value of x, which is my axis of symmetry. So then I draw a dotted line down the axis of symmetry because that's where my vertex is going to fall. And I look at the front and I know that it's positive. So I know that my graph, it is going to open up. Okay, if it was negative, the parabola would be opening down. Okay, then I have to find, once I have found the axis of symmetry and x, I need to find the vertex, which is the ordered pair x, y. So then I'm going to take the original equation, I'm going to substitute the value of x in there, which x was -1 in this case, and then I find that my y is -7, so my vertex is going to be at -1, -7, which is going to be the minimum of the graph because it's a positive a in the front. So we know that the graph is opening up. So I know that's my minimum point. I'm going to go ahead and graph it. And then using the same equation, I'm going to find the y-intercept because, and I know in y-intercept, my ordered pair is 0, y, because x is 0. And so I'm just going to substitute 0 into that same equation to calculate y. And that'll be my y-intercept. And then after that, I'm going to use the same equation and try to find another point. I always like to choose the right because then I can reflect it on the left of the axis of symmetry. Okay, so then in this case, I took 2 and I substituted that again into the equation and I found out what 2 positive 2 would be. And then, like, as I can see, this is 1, 2, 3 from the axis of symmetry. So same thing I would take on the left, 1, 2, 3. And then I just connect with a smooth curve or the parabola, and that's how you graph a quadratic function. So here's another problem, and we have been given the equation f of x, which is y, is equal to 2x squared minus 8x plus 2. Okay, so what we can do in this is we can use a table of values to graph a quadratic function. But first thing, we are definitely going to use, the axis of symmetry equation because we are trying to find what is the axis of symmetry. So, once again, this is my A, this is my B. And of course, this is my c because we have y is equal to ax squared plus bx plus c, right? So it's written in that standard form. So now to find the axis of symmetry, I am going to use the formula for that, which is opposite of b over 2a. And so when I do that, I have minus, and what is the opposite? Of course, we are going to do minus, and what is that? We have negative 8, and that's going to become positive, right? But I'm just going to write it over here. Minus negative 8 over, what do I have? 2 times what is my x, and that is going to give me 2, right? Because that is what my, my a is 2. And so therefore, when I am doing this, what is negative? I told you it's going to become opposite of that, and that is what? Positive. So that is saying 8 over 4, and so therefore this is going to be 2. So what is my axis of symmetry? So this is my x is equal to 2. So first thing, I will go to 2, and I can just go ahead and make my dotted line. Okay, I'm going to make my dotted line on 2. So this is my axis of symmetry. Okay, now next thing what I can do is I can create a table to find the other values. So I'm just going to go ahead and create a table like this. Okay, and I'm going to have x and y. And then I'm going to put some values, 1, 2, 3, 4, 5. And let's say I say x is 0, 1, 2, 3, 4. Okay. And so I already found, that if we have, we can go ahead and find our values by putting into the equation. Or I can have the table to complete it. And I have 2, and I have negative 4. I have negative 6, I have negative 4, and I have 2. Okay, so I can create a table like this. And I can see that, once again, what did I say? My axis of symmetry was 2. And then my y-intercept is going to be what? If x is 0 and my y is 2. So my y-intercept is going to be 2. Okay? And the vertex of this function is a minimum. Okay? So we are looking at, and why are we saying minimum? Because this is positive. So it's going to be moving upwards. Okay? So therefore, the vertex of the function, what's the minimum that I see over here? I see 2, -6, right? And so therefore, when I'm looking at this table, I know that 2, -6 is my minimum. So 2, -6, and this is where my vertex is going to be. All right. And then, of course, I know my y-intercept is at 0, 2. Okay, so if I have 0, 2 here, and I have same distance on the other side. And then I can see my other values. I have 1 and I have -4. So this is going to be same distance on the other side. Okay, I have 3 and I have -4. So look, same thing. And then I have 4 and 2, which is here. And literally, guys, all I can do is take the initial equation, which is 2x squared minus 8x plus 2, and input those values for x. So all I'm doing is, like, let's say for 3, I am doing 2 times 3 squared minus 8 times 3 plus 2. And that's how I can create this table. So I'm just substituting those values, okay? And then I can just graph this, and I can make this smooth curve like this. Okay, and that is my graphing using a table. And so the parabola extends to infinity, so the domain is all real numbers. Okay, domain is all real numbers. Okay, and my range is going to be a set, as this is the lowest point, right? So my range is going to be the set. So y, the set of y, so that y is greater than equal to 6. And that is my range, because you can see that's the lowest point, and then everything is above. Okay, and that's how we graph this. So once again, you are welcome to go ahead, put individual points, or you can just create a table and then you can graph it. And in a table, we know that if x is 0 and whatever the value for y is, that is going to be the y-intercept. Okay. I also wanted to show you that we can definitely use a graphing calculator to find the graph of the equation. Okay, and so once again, literally you are just putting in your equation that you are trying to graph, and you can use a graphing calculator to analyze the key features of quadratic functions by graphing or by using the table feature. And it depends where the graph is existing, depending on the problem, whether it's only in quadrant 1 or quadrant, all the quadrants, etc. And so again, this is something that will be worked on in the classroom, but a graphing calculator can definitely be used. And I wanted to show you how you can just look at the points and know the key features that the graphing calculator pulls up. You can see the axis of symmetry, where's the vertex, what is the end behavior, where's the y-intercept. So looking at that, it is going to plot everything for you also. So I just wanted to just show you that really quick. So I'm just going to go ahead and do one last example so that this concept is super clear to you all. Okay, so once again, we know the standard form of a quadratic equation is y is equal to ax squared plus bx plus c. Okay, so now we have this over here. My a is going to be 1, my b is going to be -6, and then I have my c. Okay, so first thing, I am going to find the axis of symmetry by following the formula where I have x is equal to opposite of b over 2a. So if b is -6, what is the opposite of -6? Is +6 over 2 times 1, because that is what my a is, and that is 6 divided by 2, because 2 times 1 is 2. I get 3. So my axis of symmetry is 3. So I'm going to go to my graph, and I'm going to go to 3, and I am going to put a line up there. So I'm just graphing it. Okay, there we go. Sorry, it's not the straightest. There we go. All right. So once I have this, then I need to find what is the vertex. So I'm going to go here, and I'm going to take my, I already have x, which in the vertex, I have my x. I need to find out what y is. So I'm going to take the original equation, which is y is equal to x squared minus 6x plus 4. And then I am going to input the value of x in here, which is, I just found that with the axis of symmetry. So y is equal to, we have 3 squared minus 6 times 3 plus 4. So what am I going to get over here? I'm going to get 9 minus 18 plus 4. So this gives me negative 9 plus 4. And so therefore y is going to be negative 5. So my vertex is 3, negative 5. So I'm going to go ahead and plot that. So 3, negative 5. Here is my vertex. Okay? And then next thing I'm going to do is find the y-intercept. And to find the y-intercept, I know that x is 0. Okay? So in y-intercept, my x is 0. So what I'm doing is, I am going to be doing 0 and something that I'm going to get here, right? So I'm going to go ahead and use the same equation. Y is equal to x squared minus 6x plus 4. So 0 squared minus 6 times 0 plus 4. And so I end up with 4. So 0, 4 is my ordered pair. That means the graph is going to be cutting or intersecting the y-axis at 4. Okay, so that means 0, 4 over here. And if I have this, and this is 1, 2, 3 away, I'm going to do the same thing here, 1, 2, 3 away. Okay, and so what I'm going to do, I always like to work with a number to the right. So I'm going to go ahead and choose 4. So I'm going to plug in a value for x to find more points on the graph. Okay, to find points on the graph, I'm going to plug in another value. I'm going to take the original equation, which is x squared minus 6x plus 4. And let's say I'm going to give the value, let x be equal to 4. Okay, and if I say x is equal to 4, I have x squared, which is 4 squared minus 6 times 4 plus 4. And 4 squared is 16 minus 24 plus 4. Right? And so if I do 16 plus 4, that's 20. And 20 minus 24, I get negative 4. Okay? So now I see if I have 4, if x is 4, y is going to be negative 4. Okay? So if this is here, one more over here, this is going to be the other side. And then once I have my points, I just make a smooth curve and create my parabola. And there you go. And that's how easy it is to graph a quadratic function. Okay? So, once again, that is graphing quadratic functions. We know the standard form of quadratic functions, which is, remember, it's a nonlinear function, but it is a function because it passes the vertical line test, which we have talked about in a previous unit. And so f of x is equal to ax squared plus bx plus c. That is my standard form. And when I need to graph it, of course, I am going to write it in the axis of symmetry form, where x is equal to the opposite of b divided by 2 times a. Okay? And then, of course, so once I found the axis of symmetry, put the dotted line straight down, find the vertex, because you've already found x. So you're going to substitute that x into your ax squared plus bx plus c, whatever formula, whatever equation was given to calculate what y is, and that'll give you the xy, and that'll tell you the vertex. Then you look at the first part, the leading coefficient. If it is positive, then guess what? The graph is curved upwards, open upwards. And if it is negative, it will be opening downwards. So then we'll know that whether the vertex is the highest or the lowest point, depending on that positive or the negative. Okay? And then, of course, we are going to find the y-intercept by using the same equation. And we are putting our 0 as x, because whenever x is 0, then we have a value for y. It's always 0 something, right? So then we calculate what the y-intercept is, and then we give another value to x, and we find another point on the graph. And so then again we are plotting based on symmetry, and then we just connect all the dots with a curved line. Okay, and that is graphing quadratic functions. Easy breezy. Okay, so you all have a fabulous day.